Oh, super slow-mo. Here we go.
Yeah, this is going to take forever, Reimer.
Good Lord.
Intro to moles and stoichiometry.
Yeah, Milk's here.
With Milks
MoNaCo.
and MoNaCo.
Yep. So we're going to do an intro video for you guys this time.
Yeah, first time ever.
Right, new unit. So we're actually going to show you with real chemistry, right up there, what you're going to be able to do at the end of the unit.
Right, we're covering the whole skill set in this one problem ahead of time.
Right, and we're going to then do the unit. You're going to learn each little step along the way to encompass this whole big thing.
We wanted to give you an arc for the whole thing.
Right.
The more you know.
There you go. So here's the problem. We want to create 2.5 grams of this silver chloride. We can name these all from last unit, right?
Yeah.
We got NaCl, 1 mole of NaCl.
Sodium chloride,
Yep. Going to react with 1 mole of AgNO3.
silver nitrate,
There you go. Going to produce 1 mole of AgCl
silver chloride,
and 1 mole of NaNO3.
sodium nitrate.
So the problem we are presented with is we want to make 2.5 grams of this stuff.
Because this stuff reacts with light to turn black, and Rochester's a photo city.
Great Kodak.
We're going back 150 years to the roots of this city. This chemical put in photographic paper makes it turn black when it's hit by light. So we want to make some of that stuff.
To make paper photoactive.
But we can't just keep it in a bottle on the shelf because it reacts with the light.
So it's very sensitive stuff.
Right. So we got to make it from two things that are super stable right here in the lab, and then we have to use it.
Right, and what you're saying is I don't want to make 250 grams of
Nope.
it, because I'll lose it, it'll react. So we're going to make small amounts of it.
It goes bad.
In time. So the problem we have now here is how much of this and how much of this.
Grams.
How much in grams does Mr. MoNaCo have to do in the lab? Let's show him the lab real quick.
Yep.
We're going to do it.
Don't mind the mess. Yeah, so I'm gonna weigh out all this stuff while Mr. Milks does the mathematics. He's gonna tell me how many grams of each to put on my weigh papers that I can put in my test tubes, which I can dilute with my water, and then react in this vessel that's dark because it keeps the light out.
Perfect.
And then I'll filter it and dry it out overnight, and we'll have a second video to see if we did it right.
Right, see how much we made.
So, Milks
go.
the math man.
So here's some numbers we did ahead of time. This is called gram formula mass, one of the first things we'll be able to learn how to do. And what we're going to do is I want to get 2.5 grams of AgCl, so that's where we're going to start. I'm going to start with 2.5 grams of AgCl. I'm going to be very religious with my units. I want my units all the time. What I need to do is convert this into moles of AgCl, and I know that 143 grams of AgCl, silver chloride, is 1 mole. This is a unit conversion piece right here. I'm going to multiply that. When I do that, my grams of AgCl are going to cancel out with my grams of AgCl if I set it up right. So we're going to learn how to set these bad boys up. Now I'm going to be in moles of AgCl. Let me keep my units right. So I need the moles of AgCl to be in the denominator of the next unit so it cancels out. And according to my balanced chemical equation, I know that 1 mole of AgCl is going to produce, is going to come from 1 mole of silver nitrate. So 1-to-1 ratio. So I'm going to use that ratio here. I'm going to put moles of AgCl on the bottom. And on the top, I'm going to do that 1 mole of AgNO3. Because they are in a 1-to-1 ratio in my chemical balance equation, my balanced chemical equation. Now my moles of AgCl are going to cancel out. And now I'm in moles of AgNO3. I got to get back to grams so Mr. MoNaCo knows how much to weigh out. The gram formula mass of silver nitrate is 170. I'm in moles, so moles is going to be on the denominator, so it cancels. Mr. MoNaCo, you got a calculator handy?
You know it. 2.97 grams is going to be your overall result. But
Oh, you're good.
got the calculator. All batteries are low.
So boom, boom. So it's really going to be in your calculator. You're going to do
2.5 divided by 143
equals.
0.01760.
Then multiply it by 170.
2.99
2.99 grams.
grams AgNO3
NO3 is what I'm left with.
And I'm going to go start weighing that out while you do the
Next calculation, so you know how much
salt to add, sodium chloride. So
Yeah, sodium
I'm going to go
chloride.
weigh that out.
Okay, good.
While you work on the next calculation. Here's
Perfect. So again, I'm going to start with what I have, the product I want to get. I'm going to have to do this 2 times because I need to know 2 different chemicals to weigh up. So AgCl, I know it seems a little redundant. First step's going to be the same, which is nice because I'm still in grams of AgCl, so I'm going to put grams of AgCl on the bottom. Silver chloride is 1 mole of silver chloride. Grams cancels. Now I'm in moles of silver chloride. I know that 1 mole of 8 silver chloride is going to react 1 mole of NaCl. So I just converted from one to the other. Moles cancels. Now I'm into moles of NaCl. I know over here that sodium chloride is 58 grams. And I'm going to need that on the top. 58 grams of sodium chloride per 1 mole of sodium chloride. Now in our calculator, you at home would put in 2.5 divided by 143 equals,
Yep. 0.017.
and then times 58,
1.01.
1.01 grams of sodium chloride. So, according to our calculations,
I'll go weigh that out. Well, I'll get ready to weigh that.
almost 3 grams, 2.99 grams of silver nitrate,
Yep.
and 1.01 grams of sodium chloride. If I make 2 solutions of those,
Yep.
put them together, let it react, dry it out, should produce 2.5 grams of AgCl, silver chloride, just like we want. So here we go.
So let's check it out. So what I have here is the first chemical Mr. Milks told me to weigh out is AgNO3. On my balance here I see it says 3.01 grams.
Pretty close.
This number I wrote on the piece of paper, 0.88 grams, is how much the paper itself weighed. So in case I make a mistake, I know where I can go back to. Okay, so I have 3.01 grams. It's a little bit more than I was supposed to, but that's okay. That's okay. I'm going to add a little bit more salt than I was supposed to. I got a test tube, labeled it up, AgNO3 with an AQ on it. AQ means that I'm going to dissolve this stuff in water. So I just pour very gently. Also add a little extra because some always get stuck on the paper. And I've measured out 10 mils of water, roughly. It's not exactly 10 mils. The amount of water doesn't really matter. I just need all this stuff to dissolve. Now, according to my solubility stuff, it should all dissolve. Ooh, surprising.
Was it hot?
No, opposite.
Cold?
Yeah,
Ooh.
that's really cool.
Endo.
Endothermic reaction.
Endo.
Plugged it up. Mr. Milks is going to shake and dissolve all that while I weigh
I can do
out
that.
the other one.
I can do that.
Notice that's gotten a little bit cloudy, probably because there's some sodium chloride in our water supply in the
being
first
reacted.
place. So
Right.
it's
You
already
can even
starting
hear the
to
crystals
react
a little bit.
to make that stuff that we're looking for. So NaCl, I've got this paper weighs 0.91 grams. I'm going to zero my scale. Now, Mr. Milks told me I'm supposed to put 1 gram of NaCl in.
Yep.
Now, I'm going to go a little bit more because I want to make sure all the silver nitrate reacts with sodium chloride. And if there's extra sodium chloride, that's almost a sure bet.
While you're doing this, I have a great question for you.
Yeah.
Why would you not use more silver chloride?
Because the silver chloride's expensive.
There you
It's
go.
got silver in it. So for that
Precious
reason,
metal.
it's a precious metal, and the chemical itself is rather expensive. Now, the limiting reactant, we want to use up all the silver chloride, silver nitrate, and turn it into silver chloride. So we want this to all be used up. So we add extra of the other ingredient, a little bit, so that it does.
Right.
This is sodium chloride. I'm adding to a test tube, just like before.
Right. If we were to have to pick in this reaction, we wouldn't want to have extra silver laying around. We want
No.
to use all that.
And so I'm just going to give it a nice 10 mils of squirt of water or so. Again, I need these two chemicals to be in liquid form to react properly. If I mix the two powders, according to the equation up there, they're supposed to react.
Right.
But in reality, it would happen really, really slow. So when we get these ionic compounds dissolved in water, the ions are free to move around. And when they bump into each other, they will react. So when this stuff, the ions in here that have dissolved, dissociated, react with the ions in here that have dissolved and dissociated, we'll get more white powder. So I got to just make sure that's all gone right there. And I'm going to react it in this light-proof vessel. Push down, unscrew open. I'm going to get my stir bar going in there a little bit. Yep, I'm going to add the salt in first. All right, so just good old table salt. It's clear now. Okay, it's all dissolved. Add that in. Whoop. In it goes. And let's turn up the spin a little bit, just gentle, not a ton. Okay, and then I'm going to add our silver nitrate, aqueous, to the same reaction.
Don't get any on you.
Try not to get any on me because it will react with the sodium chloride in my skin, and I'm guaranteeing you I just got some on me.
Nice.
So maybe in a few minutes we'll see my fingers turn black, or in tomorrow morning's video when it's dried up, I bet you my fingers will have turned black.
I can tell you the geeky thing.
Come on in here, Ms. Reimer. Check this stuff out. So look at that sludge in there. See, it kind of looks like weird, gooey, spoiled milk. That is the photoreactive chemical that we wanted to create. And so we're going to crank up the volume here, turn it up to 11, shake it up real good like, and look in there. Look at this funky sludge, right? That's the chemical compound silver chloride that we wanted to make. You know a reaction occurred because we got this solid to form after we mixed two liquids.
There's a chemistry word for that solid.
It's not really hot, but it's a little warmer than I was expecting.
Oh, it is a little bit warm. Oh, it's good. After that cold one, this feels better.
Yeah, for sure. So this was an exothermic reaction.
There you go.
And what's the cool science name for the solid forming?
Oh, precipitation.
There we go.
Right. If
So
this
it's
were
a
to
precipitate.
it actually, you can see it falling to the bottom now.
There
So
it is.
it precipitates by falling to the bottom, which is kind of a
the way
living,
the rain
an earth
falls,
science
right?
term. Yeah. I don't know what the true origin of that word is, but I got the sludge, and now I have to do a filtration.
Okay. Do you want me to turn off the lights for the filtration?
We can get it started in the regular light. We're going to turn out the light in a minute. Now notice, I have another filter paper. I've written the mass of this on there. Why would I do that, Mr. Milks?
Because tomorrow when we mass this, you're going to mass it on the paper.
Right. I need to know how much the paper had
Because
weighed.
we're going to subtract it out.
Because
to
we're
get
going to
the mass of
subtract.
the powder. Right.
And also, I need to get my filter paper to stick in there pretty well, so I put a little water in there so the cone stays. And this filtration is going to take a while. Look, see, look. 1 drip, 2 drips, 3 drips. That's why we're going to set this up, and we're going to leave it overnight.
There you go.
So I'm going to have to do a couple rinses, obviously. So I've got, there we go, got our white powder into our container, and I'm going to rinse it out with some more water. Okay, I'm going to leave the stir bar in there because it's all right.
Take it out tomorrow.
Yeah, we'll take it out right before we mass it. Now I can guarantee you,
slow down.
whoa, overflow.
Slow
Should have
down.
used a bigger filter.
Yeah.
Now look here. We're gonna have some waste. We're gonna lose some chemical. So of that 2.5 grams I was supposed to make,
Maybe we'll make 1.3
Or a little less.
Not 1.3, but like 2.3
right?
or 2.
And it's tough to see, but there's still some stuck on the inside of the bottle.
Right.
Right now the filtration's going pretty good. Maybe I can get lucky and get some of this out of there. No.
So just as a preview for tomorrow's video, I want to find out. I got a feeling working at Kodak with this stuff as long as I did. Mr. MoNaCo's hands are going to turn black today.
Yep.
As soon as he walks outside into the sunlight.
In the sunlight, because sunlight's got more energy than these tube lights. So.
It used to happen to me all the time on the way home
Yeah.
from work.
Yeah.
It's
I'm
6,
gonna keep
6
that all
o'clock
up
in the
there.
morning when I'm leaving. My hands hit the steering wheel, and all of a sudden I get black spots. And I had no
spots.
idea it was on me all night.
But it's a really nice white powdered granule. It's kind of cool
nice.
the way it works. So I'm going to put the lid on to keep it from reacting overnight. And so we have a nice
dry it
white powder
overnight.
in the morning.
Tomorrow we will.
Yeah, I actually feel my fingers are nice and slick already.
Oh, nice.
There's a little bit of a
So
extra
tomorrow we'll weigh it
reaction.
and see if our if the proof's in the pudding. We'll see if our calculations were
We'll
good.
see if
and
we
our
actually
techniques were
made
all right.
2.5 grams of this stuff like we were supposed to. We'll see if my sloppy analytical technique, I mean, there's probably a few milligrams there, I have a feeling like we probably made most of what we were supposed to.
Yeah.
But the whole moral of this story is that we took a chemical equation and a target amount and decided, okay, I can work backwards to find out how much mass of ingredients I needed to start. It's kind of exactly what you do when you're planning a party. Having 50 guests, I want to have 50 chocolate chip cookies. This recipe is only for this many. How many pieces of each ingredient do I need to start with so that I get what I want at the end?
And that's a really great analogy. I mean, this is really these balanced chemical equations.
It's a recipe.
They're really a recipe, but it's a chemical recipe.
Right,
For
and
a
we're not
reaction.
talking about 10 cookies or 100 cookies, we're talking about grams of a particular chemical compound.
Right.
So this is what industry does, this is what Kodak did for years, this is what John and I did in the lab many times.
And listen, this is what we do right now when we got to make solutions for you guys for lab. We
Right.
have to do these kind of things. We have to do the dilutions. We
Yep.
have to do some of this kind of chemistry. So moles, there's a new word. We're probably one of the first things we're going to get into is what is a mole, and then we're going to learn how to do this whole GFM
Figure out the gram
thing.
for the mass, which is the key to
Yep.
these calculations.
Yep. And then we'll learn how to balance equations, and it's going to
Then
be a
we're going to learn how
stepwise
to
process.
do the
It's good.
ratios, and we're
It's
going to
good.
learn about all this stuff. So thanks for watching. I know it was a little long, but this is what we do, and we wanted to show you.
There you
So
go.
have a good one. Thanks,
See you
Ms.
guys.
Reimer. Give yourself a shout out.
Woohoo!
See you guys tomorrow.